Yeah. Okay. That does not say it's not a Z. Okay. So let's talk about when we're talking about lines in chapter 5. There's a variety of ways to represent lines. We talked about direct variation, which was like y equals kx. We talked about slope. So we're talking about probably the most popular form of representing a line in an Algebra 1 class is slope-intercept form. And so let's talk about that. Okay, what does it mean? Slope-intercept form. Well, it's exactly what it says. You need a slope and you need a y-intercept. If you have those two things, you can create slope-intercept form. And of course, it is this, y equals mx plus b. I'm sure that you have seen this before, all right? M stands for what? The slope. Exactly. All right, what does the b stand for? The y-intercept. It's not the x-intercept, it's the y-intercept, all right? Many students put the x-intercept down there. That's not what that means. So, no, but I can see that happening too, okay? So slope-intercept form is y equals mx plus b. All you need is the slope and the intercept, and you've got it. You're good to go. Okay, here's an example. Y equals 5x minus 2. So first thing I'm going to ask you, is this equation the equation of a line? How do you know? How do you know?
Because it has a slope and it has the y-intercept.
Well, okay. What if I did this? Okay. Now is that an equation of a line? Well, what did I change the 5 or the 2? No, I didn't. So what makes it a line? Yeah.
The fraction sort of, like, that's like a simplified thing.
Well, the thing that makes it a line is the exponent on the variable x. It's a 1, right? If my exponent is a 2 or a 3 or something like that, it's not a line anymore. So the first thing we have to realize is, okay, yes, we're dealing with a line. Okay? Once that we realize that we have a line, we can start to talk about the slope and the y-intercept. So the 5 represents what? The slope. Good. Now, when I say the slope is 5, what do I mean by that? What do I mean by the slope is 5?
You rise 5.
You rise 5 units and you go over 1 unit. So up 5 over 1. Good. Okay. And then what does this negative 2 mean?
That's the y-intercept.
That-
The point is 0, 2.
The y-intercept and the point is 0, 2. Yes. Okay. Well, we seem to be doing pretty well on this part. Right? Okay. Pretty straightforward, but here's another type of example. They might give you a slope and they might give you a y-intercept, and they say just simply put this into slope-intercept form. So we would start with, okay, we know that slope-intercept form is y equals mx plus b, and we know that the slope is negative 4/5. So we'd have negative 4/5 x, and we know the b is positive 7, and that would be how you do it. All right, another type of example that you could see from slope-intercept form is they could give you 2 points. And they say put the equation into slope-intercept form. All right, so we'll actually work this one out together. So the first thing that you want to do, or the first thing that I always do, is I label my points. This is my first set of x and y. This is my second set of x and y. So I have x1 and y1 and x2 and y2. All right, so I need to get the slope. I'm going to remember that there's a formula for the slope, and it is this. The formula for slope is y2 minus y1 over x2 minus x1. Okay, I'm going to go ahead and continue. I know the value of y2 is what in this case?
Negative 8.
Negative 8. Jay knows what it is. It's negative 8. Okay. Minus, what's the value of y1 in this case? Everybody. 1. Very good. What's the value of x2 in this case? 5. Minus, what's the value of x1 in this case? 2. Very good. Let's go ahead and compute that. That's negative 9 divided by 3. That is negative 3 over 1. So now I know the slope is negative 3 over 1. Okay, we're doing well so far. So I'm going to do this. Y is equal to mx plus b. Y is equal to negative 3x plus b. Okay, now that I get to here, I don't have a y-intercept. How do I get it? I plug in any one of the points that we want. Which one do you guys want to plug in? 2, 1. Okay, it doesn't matter. You can use either point. You'll get the same answer because the points are both on the same line. So if we're going to use 2 and 1, we're going to say this. 1 is equal to negative 3 times 2 plus b. So therefore, 1 is equal to negative 6 plus b. I'm going to add 6 to both sides, so 7 is worth b. Therefore, when I'm all said and done, I get y is equal to my original slope, which was negative 3x plus 7. So if I have done this correctly, negative 3x plus 7 should have the points 2, 1 and 5, negative 8 passing through them. So I'm going to go ahead and check to make sure that that's indeed correct. So we had this. We had the line y equals negative 3x plus 7. Is that true? Okay, so there is this line, negative 3x plus 7. What were the 2 points? 2, 1. Let's put that one on there. 2, 1. Does that look like it's on the line there? Yeah, what was the other point? 5, negative 8.
How about 0, 6?
Put that one on there. Is that one on the line as well?
Yeah.
It sure looks like it to me. So I'm going to make these a little bit thicker so we can see. And then this one a little bit thicker so we can see. But yeah, it looks to me like both of those points, right, are on the line right there. So I have the blue one there, and then I have the green one there. Okay, you try in your groups right now, go ahead and set up a graph and graph the line y equals 2x minus 1. Okay, so hopefully you guys have the same graph I do, right? I have a slope of 2, I have a y-intercept at negative 1, I have those 2 points on there, and it should look something very, very similar to mine.